Of course, I believe you are pretty much aware on the architecture and design point of view, right?
Yes, yes.
Okay, and what are the tools you used earlier for the architecture and design?
See, architecture design I haven't done. Like I was associated with an architect and I was mainly working with him. I haven't done that. Like I don't know if I was told that this is part of that interview or not.
Oh, okay. So mainly you have worked on the management point of view, is
Not
it?
on the management part, on say I can say POCs, and then designing the application on say for example the last application that I was working on. So it was moving Pega to Camunda. So in that how the application should look like, how the Spring Boot microservices that we were developing, how they'll communicate, what will be the designs that we'll use, what will be the kind of patterns that we'll use to get the application to the end. I'm involved in all those kind of discussions.
Okay, okay, okay. So you know like how the systems are talking to each other, but
Uh,
you are not engaged in the architecting the application, right?
yes.
Okay, okay, got it. And web-based applications, you are good also?
Yeah, actually.
Okay. What is the framework you have used from website?
Uh, See, I haven't worked on the front side, but I have worked on the back end side. So there again, we had used this one, Spring Boot only.
Okay, Spring Boot to the backend side. Okay, got it, got it.
Yeah.
So, from the microservices point of view, we'll go first, okay? Then
Yeah,
we'll
sure.
go other side, okay? So,
Yeah.
can you talk about some design perspective on the microservices? You know any design architecture principles?
Yeah, so when I talk about microservices, I know a few of the architectural designs of microservices. You have this pub sub architecture where one is the publisher and the other is the subscriber. You can use certain kind of message brokers in between, and in your REST template, you can define a publisher and subscriber. So what happens is a publisher will publish a topic, and that topic will be available to the subscriber through a channel. That topic will be available, and whenever the subscriber wants to hear to that particular hear to that particular topic, they can actually listen to it. Then there are other patterns like API gateways there. Then you have this event driven architecture, then CQRS.
Yeah.
Yeah.
Okay.
So, for example, when I talk about CQRS, there we can do this command and query segregation, where it is mainly used in the kind of application where the query is more than the commands, like writing the data is less than retrieving the data. So, in those kind of applications, for example, e-commerce and all those kind of applications, we can basically go for this CQRS, where we can create a different service for the query and different service for the command. We can put a MQ in between, and like or a Kafka broker in between, and then we can do this kind of application where whenever you are putting the data, there will be a topic published, and the subscriber will get that data and updates its DB. That we can do. And then there is this circuit breaker architecture that is there, where we say whenever we talk about circuit is something like it is. Say for example, when we talk about the electric circuit, right? So electric circuit is something like it is when we say it is open, that means the flow is there. So when we say the circuit is open in microservices, it means the microservice client is able to hit the microservice. When we say it is closed, that means it is not able to hit the microservice. So we define certain type of parameters there. Say for example, I'll define what is half open, what is closed, and in that scenario, if it is closed, I can put a strict server and then give the meaningful answer there. Then again we have this API gateway, where we define we put an API gateway in between that behaves like a proxy server to those microservices, and microservices will flow from there. And say for example, if the microservice is down or something like that, then we can put a Histrix server there, and then it can basically tell you like the microservice is down and it is not giving the response kind of, instead of just breaking the service kind of thing.
Okay, got it. Yeah, so few design principles, of course, you told, right? Pops up, then fault tolerance, right? Circuit
Yeah.
breaker, yeah. Then you told another one, API gateway. Okay, so can you tell the scalability? What is scalability?
So basically, scalability in terms of microservices.
Yeah, yeah.
So scalability, when I talk about scalability, it is like it should be able to handle the incoming data basically. Incoming request, not data. So whenever we talk about this scalability, it is like it should be fault tolerant, and it should be designed in a way that it can handle multiple, like the number of requests it handles. It should be in a way that it should not break, like with the number of requests coming in.
Okay, okay. So how many types of scalable options are there? What are the different scalability?
Scalable options I when
I think there are two, right? Horizontal and vertical.
Yeah, horizontal and vertical. So when we talk about horizontal, is like we can add different instances, and when we talk about vertical, it is like we can add more CPU or something like that, right?
Okay, so in microservices point of view, what is the one it uses by default?
By default, I think we'll be using vertical.
Okay, okay. So it increases the CPU memory in the same machine.
No, it will not increase. Sorry, then it should be horizontal. It cannot increase by itself, right? You have to increase
Okay, so horizontal means you are increasing the number of instances.
instances. Yeah.
Okay, okay, got it. Okay, so suppose in the microservices, right? So you are using Spring Boot, right?
Yes.
Okay. So what are the different ways you are creating the Spring Boot project, or you are using which method?
To create a Spring project,
Yeah.
we can use this initializer, basically Spring initializer.
Okay. Okay.
Yeah.
And you have worked on cross-cutting concerns in the in your services.
And cost cutting in microservices
Yeah.
again.
Yeah. 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 Yeah.
Yeah, like a few I have seen. Like I haven't, I was not part of the decision there, but like I have seen a few examples there.
Okay. Okay. So
Yeah.
when you talk like on the tracing point of view, because
Hmm.
there might be how many microservices you have in your project now?
I think there are around 6 to 7 microservices in the
Okay, so
current
suppose
project.
the 6 to 7 microservices are talking, right,
Hmm.
then to each other, and somewhere there is a issue, right? So there you need
Okay.
tracing, you need to trace, right? So how do you do that?
See, we can configure this tracing in the API gateway, like logging in the API gateway, we can configure. And when we do so, what happens is, like if we do it only on the microservices side, it will give me the tracing for that particular microservice. But if I do it on the API gateway side, it will basically give me an end-to-end tracing, like when one service is calling the other service, and that way, basically.
So which cloud you use?
See, the current project we are using Azure.
Azure. Okay, okay, got it. So Azure, you know what are the different services, you know?
See, on the Azure side, I don't know. I'm familiar with AWS. Azure actually, thing is, I'm working for Morgan Stanley, so there everything is a wrapper. So whatever, like we just get something like we get certain set of commands to deploy the application and all. So it is not like we are doing it on our own.
Okay, okay, got it.
Yeah.
So when a new feature, right, something comes up or some requirement, new requirement, so how do
Yeah.
you follow that, how do you do that, how do you put into the design, and how do you make sure that this solution will work properly?
So, for example, if a new request will come, basically the first thing will be to estimate, right? And then after the estimation is done, we have to think about the current solution that is working with that we are working with. So, for example, I already have a couple of microservices, and then I get a request to develop a new microservice that should interact with the other microservice as well. So I have to think about the on the DB perspective, like what my DB should look like, and then on the okay. On the this one communication perspective, what the communication should be between the microservice, what will be the kind of set of input that I will be providing, and what will be the set of responses that I should get. So all those things needs to be considered while designing the new feature actually.
Okay, what are the different diagrams you create for that?
For us, we are creating certain kind of flow diagrams that we are creating. We are creating class level diagrams also for the application perspective.
Okay, okay. And how do you deploy your application into cloud?
So as I told you, right, for the current projects, like from the I'm working from Morgan Stanley from last 3.5 years. So for us, it is like we have this wrappers; those are available to us to deploy the applications on the cloud. So we don't do it on ourselves there.
No, I mean, you know that what is the application looks like when it is deploying, right?
Yes, yes.
Yes, so that's you can tell it.
So, for example, when we are developing this application, right? So, when we deploy the application on the server, so what happens is we follow a certain release mechanism there. So, for example, we'll do a distribution first. Once the distribution is done, we'll do a build on that particular machine, and once the build is done, then we'll do a deploy. So, when we do a deploy, basically it will point to a particular location from where the application.var should be picked, and it should be taken up for the execution.
Mm-hmm. Okay. And so, as part of the management of the memory, how do you make sure your application is not taking much memory?
See, uh, part, see, it was not done in the current project, but I can tell you something about from the last projects and all. So what we do is we like code refactoring is the one practice that we follow, and then um, like we also can do this basically the application will go into the containers, right? So we can do this what we say optimize the data containers that are there that we can use, right? And then code abstractions are some of the techniques, code refactoring is some of the techniques, and then serializing the data basically. So these kind of practices that we can follow to go with the memory management actually.
No, no, you can follow, but how do you make sure that
Mm.
your application which is running in the cloud is not throwing
Mm.
that error, right? You have to see somewhere, right? you have to see somewhere, or you can see somewhere in the application also or in cloud, that your memory is this much is taken.
Okay, in cloud you are asking. Okay. So see, for example, in Spring Boot, we can do these kind of settings in the actuator as well, right?
In
Or
actuator you can do it.
or only in cloud, that I'm not aware of actually.
Okay, in actuator what are the things you can do, any idea?
Like we can set these parameters actually. We can set these metrics like performance, memory, and all these things that can give me the status of these fields actually.
Okay. Okay, so yeah, that's fine. So we'll go some Java side. Okay, core Java. So you are
Yeah,
worked
sure.
on Java, which version, the latest one?
Eight.
8 you have used. Okay, so can you tell me what is consumer?
So basically, consumer is a functional interface like by the name it says it consumes. So there is a particular method that accepts a value and it doesn't like it transforms a value, but it doesn't return anything. So basically, it will be like it will return a single value and it will not return any result.
Okay, okay. So how do you make sure that your code is thread safe?
So to make sure that the code is thread safe, basically we have to uh, we have to implement certain kind of like throws mechanism or some like threading mechanism basically um, we can do this synchronization that we can use so that not multiple threads are working on a single code at a time.
I mean, shall we
Um,
use always synchronization in each method, or how?
no, there are other methods also to make thread safe. Like we can use this volatile keyword. We can use final keyword. Those things also may help me in thread
So
safety.
in your current application, did you use
Mm.
everywhere volatile or synchronized?
I have used synchronized. I have used volatile, not
Okay.
atomic or final, basically. No, final also we have used.
Okay. Normally, do you use? I mean, normally I'm saying it's like in REST API,
Uh,
right? Do you provide
yeah.
synchronized?
So normally it will be mostly final, I think, and final and volatile. Synchronization will not go because it will be like only one thread can work at a time there. And when we talk about this thread thing, mainly we use this executor services.
Yeah, exactly. Yeah, what is future? Just to remind it.
So future is it is kind of you can say it is one of the interfaces that provides you have implementations like future task and all, which provides you with a way of like if you have multiple threads running and if you want to know the intermediate data intermediate data of those running threads, you can get to know like how many threads have executed, how many threads are not executing, and based on that you can get the decision like the output of the thread can be known by the future objects. So basically it provides a way of asynchronously working with the thread.
Okay, okay, okay. Got it. So, as you were saying, right, you have not done the architecting of any application, right? I mean,
Yes.
by yourself. So, how many days it will take if I say you, can you architect this solution just by giving me a
uh,
requirement?
so okay, if I haven't done it, like I have to need to know and work on the tools. So I'll say I'll take around 1 week to 2 week to do so, from end to end, basically.
Okay, okay. So, so one problem statement. Okay, so you know different apartments and all, right? So
Different?
I mean, wherever cities is having multiple apartments. So this question is on the apartment. Okay. So
Okay.
suppose I want to build an apartment, and in the apartment, you know what are the things it has, right? Different towers, different floors, different flats, right? Different type
Yes.
of designs also it might have for the different towers, right?
Yeah.
Now, what are the design patterns you will involve to create that particular apartment object?
Okay. So to create it is only for one apartment or it is like
Only
I
one
have to.
apartment, yeah.
Okay. So design pattern that I can follow is I can go by a builder pattern in that.
Okay,
For
yeah, you can
example,
tell what is
first
a
I'll go
builder.
with the
Yeah, you can
yeah.
tell what are the design patterns you want to use and why.
So for this particular scenario, I can say I can go by a builder pattern. Why? Because first I'll go with this one. First I'll go with the towers, for example, and then I have an apartment. I have a land. I need to construct the towers first, and in that tower, once the construction, say once the what you say. The construction of first floor is completed, I can go for the second floor and then the third floor and so on. So because of which I'll go with the builder pattern.
That is the only pattern you want to use, or any other pattern also you will use?
See other pattern okay, let me think. Uh, like uh, Basically I have to go by the creational only, right? So I can go by the factory pattern as well in that. Say for example, I can do this basically in the apartments or whatever the society that we are talking about. If we have different this one different towers, they basically are usually the same. So 1 minute, I'll just decline this call. So what happens in that is uh, sorry, I was getting a call. So I just declined it.
Yeah, yeah, that's fine.
I'll just okay. When I say factory pattern, it will be like I can model it for one tower, and then I can use the same for the other towers as well.
Okay.
Uh, Similar way, like I can model one flat, and on one floor I may have four floors, four apartments, or say six flats. So I can use the same pattern in those and build the same kind of apartment, and then I can go for the same tower, and then I can build the same towers in the society.
Mm-hmm. Do you know what is blue and green deployment architecture?
Blue and green. Um,
Yeah.
Blue and green. I don't know that actually.
Oh, okay. So you know solid design principles, right? Can you talk about the in solid what is L?
L is Liskov's substitution basically. So what it says is when you have this parent-child dependencies and all those things, so your code should be written in a way that you can substitute the child with the parent.
Mm-hmm. Any example you want to give?
Example, for example, example, I can say if you want me to go by the existing one, or like I can create my own and say. If I go by my own, like for example, shape is there, then we have this rectangle, circle, and all those things. Then I should be able to substitute the shape object with the rectangle one that should be there. And if I go by For example, threads are there. I can create my own thread and give a specialty to it, or I can even substitute it with the thread directly, something like that.
Okay, okay. Okay, so so sleep method is there, right? Under which class,
Sleep is in thread only.
Okay, and wait.
Yeah. Weight is an object class.
Okay, and wait we use for what? Object or thread?
Weight will be used for thread only to wait for a particular time.
Okay, but why it is
Not
under
time.
object?
Not time. Not time. It will be used for thread object to wait until it is notified.
Okay, so why it is under object? It is not under thread.
See, why it is under object? I think because um, I think like why weight is an object. Just give me a minute. I am not able to. Just 1 minute. Let me think over it.
Yeah, yeah, sure.
Why weight is an object class? So wait, t1 dot wait.
Yeah, that's fine.
Okay.
So, you know what is 400 response code from HTTP site?
Yeah. Uh,
Yeah, what is that 400?
uh, it is bad response, I think.
Bad response. Okay, what is
Bad
201?
request. Sorry.
What is 201?
201 is successful. Okay, with like 200 is successful, and 201 is successful with when you are doing this put a patch or something like that. So 200 will be created.
200 will be created. I'm saying 201.
No, 201. Yeah, 201 will be created.
Okay, okay.
Yeah.
Okay, so suppose you are getting suppose you are getting null pointer exception in your code. You went to the log. Okay, you see somewhere there is a null pointer exception.
Mm-hmm.
So how will you make sure there will be no null pointer exception in your code in future?
See, to make sure that there is no null pointer exception, I can go by the optional classes basically.
Optional classes. Okay, so suppose somewhere there is no optional class. Okay, maybe in your
Uh,
current code, suppose optional class is not there. I mean,
okay.
suppose that version you are not using of Java, the previous version is there. How will you make sure in that?
See, in that scenario, what we can do is we can, if the basic thing to eliminate this null pointer exception in that scenario should be like we should be initializing all the objects that we are using. If we don't initialize it and then we use it, then we get into this null pointer exceptions.
Okay, so you need to change all the code, right?
Yes.
So okay, so now suppose without changing code, just for immediate action, how will you do? Any idea?
So for immediate action,
Yep.
just for immediate action, like it's not, it is null. I don't want that null pointer exception. Without changing any code at all.
Yes.
So you want to say that I don't want to get that code only, right?
No, that particular piece of code is fine. You are changing, not all code.
Okay. Can I go with this this exception handling then, and then like do this.
Okay, so null pointer exception handling, is it fine to do?
It is not fine to do, but only that particular piece of code is throwing the null pointer exception, and you want me to handle that, right?
Yeah, so did you hear about global level of exception anytime?
What?
Global global
Glo-
exception, global level of
uh,
exception.
Global exception handler, right?
Yeah, yeah.
Yeah, I have heard about it. It is we define this, we use this controller advice and do the global exception handling, and then write the exception handlers that you're talking about, right?
I mean, okay, yeah. Yeah, okay. So so suppose I have a singleton class, okay, and that
Okay.
singleton class is also implementing serializable interface. Okay, now
Okay.
there is a singleton class I have that is implementing serializable interface. Now
Okay.
you know singleton class, right? It will
Mm.
always give me a single object. Now, is this
Mhm.
a problem, or if it is a problem, how to make sure that there is always a single object?
When we do this serializable, right, it will be a problem actually. And to resolve this thing, we have to write when we do this, there is a way we define this. We uh, define the variable as transient and final, right? If I'm not wrong.
Yeah, so that is you're uh, you're not serializing at all, but there is no transient and static.
Okay. When if we are using this serializable, it may be problem into the multi-threading environment. So, to handle this, maybe we can do a this one synchronized block we can put, and then on the get instance method.
Okay, no, singleton class, right? That is already implemented with the multi-threading concept, right? So you multiple threads cannot access that. So there will be no single object will be created, but that is serialized, right? Now, if I deserialize that object, does it give another object?
Yeah, it will give another object.
Yeah. So how to make sure that there is always single object?
To make sure, we have to. Uh, there is a concept actually in that. It will when we deserialize, it will give another object, and to make sure. Um, there is a concept. I'm not able to recall it, but I had done it in recent past only. Maybe like we can do certain kind of clone or something like that. Like
Mm-hmm.
it has to do with the cloning mechanism actually.
Clone will create again the object, right?
Yeah, just 1 minute. I was getting another call. Okay. Mm, uh,
So if I have suppose
yeah,
at
I've
the
done this
runtime,
in
what you'll have, like
yeah, yeah. Tell me.
yeah. So suppose this is not serializable, okay, but
Mm-hmm.
there is a way also, right, to create multiple objects, right? You do know how to create multiple objects of singleton class also?
Yeah, there is this one thing is this clone method we can use. So what happens is when we clone it, it will basically create a new object. Um, and there's one more way
So there
that
is
we
a,
can use.
yeah, there is a reflection way.
Yeah, reflection is also there.
Yeah,
Reflection is there, then clone is there.
yeah. So
So,
yeah, for the
yeah.
reflection way, how to make sure there is no object, there is no multiple object will be created.
Okay, for reflection also, basically for all these, there are different approaches. So in the get instance method, um, the, if the reflection is there,
What are the different design patterns you worked on when you are hands on?
see, I'm on Singleton prototype and this one factory also I worked on.
Okay, okay.
Yeah.